2 days ago I got an email sadly announcing the death of Neil Bartlett, who is the scientist who's probably done most for the chemistry of xenon since it was first discovered at the end of the 19th century.
So in the balloon we've got a sample of xenon. Now xenon's one of the inert gases, but it's one of the inert gases that's right the way down the bottom of the period, so it's really, really dense. So what that means is that the gas molecules themselves are really, really large, really, really heavy, so in principle they'll sink.
Neil Bartlett discovered that xenon, which everyone had thought was a completely inert element, really could form reactions and could form compounds, something that nobody thought was possible until then. And this took place in the early 1960s. And I've got a picture here of his iconic experiment. He did his experiment, I think, in late 1962, or perhaps early 63, and this was published just over a year later. And these are two pictures. This is the experiment before and after.
So we've done an experiment here and we filled this balloon with xenon. Now xenon's very expensive, so there's about £40 worth of xenon in this balloon right now, yeah? So we're going to do this experiment and we're going to see if it sinks. And I think you'll agree that it does sink quite quickly.
What he did was he took a glass bulb of a compound of platinum hexafluoride, PTF6, which is a gas. Now that's quite unusual to have a metal compound that's a gas, but it's rather a nice bright orange gas. And he put together a piece of equipment here where in this tube here there is xenon gas, which is colourless, and this is a magnet which can be lifted up and break a tiny seal so that the two gases can mix.
But just to show you how dense it is, we've got a similar balloon, but you'll notice that this balloon is much, much higher filled, so it's much, much bigger. Now this is one that we've just blown up with air, so...
Now what had happened was, before this experiment was done with xenon, that one of Neil's students had discovered that platinum hexafluoride reacted with oxygen in air to form a compound in which one electron had been removed from the oxygen to make O2+. And this was a solid material. It was itself quite a surprising reaction. Now what Neil did was that he looked at the periodic table and wondered which other elements required about the same amount of energy as oxygen to remove one electron. And he came up with xenon. So he tried this experiment using the apparatus here. They lifted this magnet, or he lifted this magnet, it crashed down, the xenon rushed in, and suddenly this red gas was turned into a yellow solid. In fact, it turned out he was doing this experiment with his student, but the student, whose name I've forgotten, had to go home. So Neil did this experiment by himself, and he was very late getting home for his dinner, and his wife, according to him on this video, was really very angry. But chemistry had been transformed. Well, this experiment was voted by American chemists as one of the top 10 most important chemical experiments that had been done in the 20th century.
So let's see if we can compare the rates at which these two balloons will sink, so we can look at the comparative densities. Ready?
Xenon exists in the air, and when people liquefy air, they first of all separate the nitrogen and then the oxygen, and at the end they're left with the noble gases argon, krypton and xenon. So it is made from the air. And one of the problems with this price rise of xenon was that at the same time as there was a bigger demand for xenon, there was a downturn in the steel making industry, which uses a lot of oxygen. So the chemical plants that were, or the refrigeration plants that were making oxygen were switched off. So there was a smaller supply of xenon.
Whoa! That'll be the air.
This is an old-fashioned xenon lamp. The xenon in its bulb, and you put a large voltage through here, and the xenon gets very hot and shines out as a very bright light. It looks black here because the electrodes get so hot that the metal has evaporated, but xenon itself is colourless. This is a more modern xenon lamp, of the sort of lamp that is used in very powerful spotlights, for example on tanks to illuminate, that's military tanks, to illuminate the target. And the window here is made of aluminium oxide, and all the light comes out as a really very powerful beam.